Yes, dear student, good morning. Now in this video I will be telling some more term about magnetism, which generally students miss too much and they feel unable to understand many topics. So here is the term magnetic permeability. Permeability you might have learned in chemistry. Semi permeable membrane. Permeability means to allow something to pass through any material. So when we place any magnetic material in some magnetic field, the field lines are either attracted or allowed to pass through them, or they are not allowed to pass. So that ability, the ability of a material to allow the field lines, magnetic field lines, magnetic field lines, magnetic field lines, field lines to pass, the ability of material to allow the magnetic field line to pass through it, is called magnetic permeability. Magnetic permeability. In other words, you can say this is matter of language only, but we should understand basic logic. So ability to conduct the field lines also is the measure of permeability. The magnetic permeability of a material is the ratio of magnetic induction B induced and magnetizing field, that is mu is equal to B upon H. Mu is equal to B upon H. I told you paramagnetic material attract the field line, but they are weakly attracted. The ferromagnetic material is strongly attracted when placed in magnetizing field. So what does it mean? Diamagnetic material are repelled. So what does it mean? That for diamagnetic material, diamagnetic materials, mu less than 1 for paramagnetic materials, mu greater than 1, and for ferromagnetic mu much greater than 1, because it attracts field lines by large factor. The unit of mu the unit of mu. You know, mu here I told you V upon H. And you remember the unit of magnetic field or magnetic induction is Newton per ampere per meter. And unit of H, it is ampere per meter. Ampere per meter. So unit of mu is Newton per ampere square. Or if you write in Tesla, it is also Tesla upon ampere per meter. Or you can write as Tesla per ampere meter. So these units can be used for magnetic permeability. This is very important term. Without knowing all these things, we cannot understand properties of magnetic materials. So please take it serious and read it and learn it. Without this, you will always be in confusion. Permeability means permission to allow the magnetic field line to pass through a material is the permeability. Now, relative magnetic permeability. Relative magnetic permeability. For a material, we write it as mu r. For a material, relative magnetic permeability is defined as the ratio of magnetic permeability mu of the material for material relative magnetic permeability is defined as the ratio of magnetic permeability of material to the magnetic permeability of vacuum, or you can say free space. It is called mu zero. So mu r equal to mu upon mu zero. Empty space means where there is no material, and magnetic field can exist in vacuum also. Electric field can exist in vacuum also. And the ability of electric field to exist in vacuum is called electrical permittivity of electric field. Remember, these two fields can exist, magnetic field and electric field can exist in vacuum. In other medium, their ability to exist reduces. That is why the electrical force, magnetic force depend on the medium between the source of magnetic field and other material which is affected by that. Gravitational field does not depend on medium. So magnetic permeability, it is a pure number, yes. Mu upon mu zero. Mu r is a pure number. Pure number is a pure number. It means it has no unit, and its behavior in mathematics is like that dielectric constant for iron, for soft iron, or you can say for ferromagnetic material. Mu are close to 1,000, 800,000 like that. So that mu r actually is like dielectric constant. Actually, dielectric constant decreases the field while permeability increases the magnetic field. Just reverse of each other, but they are equivalent to each other in electric magnetic field. This is very important term, mu r. I will tell you while teaching about artificial magnets. Now there is term magnetic susceptibility. Susceptible, being affected by some other effect. For example, some people are susceptible to cold, means a little variation in temperature environment, they get sick. They suffer by some cold diseases like influenza, etc. Similarly, what is magnetic susceptibility? Very important term. When we place any material in magnetic field, that gets magnetized. So susceptibility is the measure of how easily a material can be magnetized. So susceptibility is the magnetic susceptibility. Susceptibility is the measure of how easily a material gets magnetized. The magnetic susceptibility is the measure of how easily a material gets magnetized. It is denoted by Gi-m. Here you can write Gi-m. Gi-m. So magnetizing field, is denoted by H, or magnetization denoted by capital M. I told you vector M equal to M upon V. Now intensity magnetization or magnetization. And what is H called? Magnetic intensity or magnetizing field. Please remember all these. So we can say the magnitude of magnetization in M is proportional to the magnitude of H, that is M proportional to H, or M equal to Gi-m into H. For low magnetizing field, here Im is constant. If we plot graph between magnetization and magnetizing field, if we take here H and here M, so for low it will remain but become constant. Why? Because magnetization defined as a net dipole moment per unit volume. So all the atomic dipoles moment present inside material become parallel to field. So further it will not increase. So for low field it is constant. For low magnetizing field, Im is constant. It is a pure number. It is a pure number. Hence has no unit. Hence Im has no unit. No unit. For diamantine material, which are slightly different, they are magnetizing opposite direction. For diamagnetic materials, Im -1, Im less than 0. यानी कि Im is negative and lies between 0 and -1 for diamagnetic material. For ferro and ferra, it is positive. For paramagnetic material, and ferromagnetic material, it is positive and more than 1. There is a slight difference I will be telling you later on while teaching the properties of magnetic material. There is slight difference between paramagnetic and diamagnetic, both temperature dependent. Now there is one very good relation. The relation between Im and mu r. Im and susceptibility, mu r relative angular. We know the magnetic induction or magnetic field inside a long solenoid having core of magnetic material is given by B equal to mu 0 Ni plus M. Here Ni, what is N, number of turn point length of solenoid, is equal to H, or M is equal to xi M into H. Ni H means magnetizing field, M intensity magnetization. So B is equal to mu 0 H plus xi M into H. Or you can write here B is equal to mu 0 h into 1 plus chi m. B upon h. Do you remember what is this? 1 plus chi m तो हो गया. But what is B upon h? My first heading was magnetic permeability. It is mu or upon mu 0 1 plus chi m. But mu upon mu 0 is equal to mu r. Hence mu r is equal to 1 plus chi m. Why? Because since mu r relative entropy is mu upon mu 0. There is a slight difference. Actually, mu r I told you nearly thousands. So nearly mu r or chi m has the same number. They are nearly equal. अब I say ना कि भाई mu r is 1000. What is chi m? So 1001. That is nearly 1000. So these terms are very important. You ask your friends and you yourself. Please make note of this video, learn it, and then it will be very easy for you to understand the properties of magnetic materials, which we keep on telling other way also. This is not good. Learn properly. Actually, many will go selected, some are not selected in spite of hard level, because when we are losing in fundamentals, then we will not be able to complete the exam. Thank you.